let's just see if this half cycle time depends on the amplitude. Because if it does depend on the amplitude, then we're going to have to worry about what the amplitude is when we're comparing it. So let's try to see if the half cycle time depends on how big these oscillations are that the spring is doing. So there's two different ways of testing that. There's the fun way, and then there's the very controlled and scientific way. Which would you like to try first, Blythe?
The fun way.
The fun way. Okay, so the fun way is to fly the ship into the blob.
Okay.
But then to continue the fire of the thrusters.
Wait, should I give it?
Yep, so ship starts from rest. And then fly it into there. Might want to zoom out just a little bit just so people can see the whole thing. There you go. Alright, so
fly it in.
Incoming. So those oscillations are pretty small, and it would be fun if you just kept on firing the thrusters to get it to have larger oscillations.
Yeah. So I'm going to try and push it this way as the spring is coming that way. So we can see now a larger peak over here.
Mm-hmm.
Try and do that again.
Okay, so that's somewhat larger than we were doing before. Now let's just leave it be and see what the half cycle time is. So has that changed the half cycle time? The larger the oscillations?
It is not.
Nope, still at 14. So it's almost as if the half cycle time is independent of the amplitude, right?
Definitely seems to suggest that.
Okay. Now a fun thing is to try to figure out when, if you want to try to pump this up even more, pump it up as much as you possibly can, you can like rotate the ship while it's attached and try to see if you can pump it up the opposite way, or you could do reverse thrusters or something. But this is something you guys can kind of play around with at home and try to see how big the oscillations you get. Okay, well let's do it in a more scientific way. And so go ahead and pause that for a second. And let's just give the ship some initial velocity. And we can change that, we can do a couple different of those initial velocities. And so we get a couple different amplitudes because it's going to have larger or smaller amplitudes. Now, why does this have to be negative, by the way?
So that it starts moving towards the blob.
That's right, yeah. So it needs to move in the negative x direction. Otherwise it would fly in the other direction. All right, here we go. Okay.
So I'm not going to...
Scientific, this is science, okay? No one's touching the keyboard. All right, what do we get? 14.1. Our time step is 0.1, right? So it's that's pretty. So it's pretty right on 14. Now, okay, so go ahead and increase that.
So they're over here. It's changing up in the corner there. So it comes a bit faster.
Mm-hmm. Yeah. And still 14.
Mm-hmm.
What is it now? 20?
It's at 20 now.
Yeah, maybe just go ahead and just kick it up to 50 or 100 or something.
Sure.
Just for fun.
Right now it's
There we go.
really zipping in there.
What about now? I'd say that's still 14.
Yeah.
So it looks like the half cycle time is it's independent of the amplitude. It doesn't depend on the amplitude. Pretty cool.
Mm-hmm.
So this is what we get for the half cycle time. How do we know this is right? So we should probably run some numbers to try to see if this number makes sense or not, so we can figure out if our code's working. So let's get out the glass board and run some numbers on this thing. Okay.